Solving a system by graphing is the first solution strategy we're going to look at for, well, solving a system. So what we're going to do is we're going to graph both of these lines on the same graph, and we're going to look to see where the lines intersect. Wherever the lines cross is where our solution to this system is going to lie, the point or points that make both equations true at the same time. So again, let's go ahead and start by graphing both of these lines on the same graph. So to do that, probably the best way is going to be to get this in the slope-intercept form. At least that's how I prefer to graph. So let's take each of our equation and solve for y. So let's start with the top equation. To get y by itself, all I need to do is subtract that 4x. So I'm going to say y equals negative 4x plus 8. There's going to be my first equation in slope-intercept form. And then next up, I'm going to solve my second equation for y. To do that, let's see, I'm going to subtract 2x first, I suppose. So negative 3y would equal negative 2x plus 18. And then to finish that, I'll need to go through and divide everything by negative 3 and simplify. So I'd have y equals negative 2 divided by negative 3 gets me a positive 2/3 x, and then minus 6 for my y-intercept. So there's the two equations we're going to graph and take a look at. But remember, what we're trying to do is find out where they intersect. My advice when you do these, put as many points down in your graph as possible. If you have a nice simple solution, your answer will be integers, and so your points will kind of lie right at the same location. Otherwise, if you have a decimal answer, at best your graph's going to be an estimate. So make your graphs as accurate as possible. Use rulers if you need to. But again, maybe we have an easy one, and our points will cross well, our points will be at the same location, so we won't really have to worry about estimating. So let's start with graphing the red line. So my y-intercept is positive 8, so count up 8. 1, 2, 3, 4, 5, 6, 7, 8 on the y-axis, and my slope is negative 4 over 1, so count down 4. 1, 2, 3, 4 over 1. And again, do that as many times as you can. The more points you have on these graphs, the easier they'll be to find where they intersect, possibly. Can I fit one more in there? Yeah. So 1, 2, 3, 4 over 1. Okay, I don't have a ruler on my iPad, so I'm going to freehand this line. I want you guys using a ruler out there to make these lines as straight as possible. So there's my first line. I guess it's not so bad. And then let's switch colors. I think I was using that color orange. And let's graph our second line. We're looking to see where the two lines cross. So my y-intercept of my second line is negative 6. 1, 2, 3, 4, 5, 6. And we have a slope of 2/3. Again, use as many points as possible. Up 2 over 3, and look what happened. Two of our points were at the exact same location. So there's my solution, but let's go ahead and finish graphing this line. So I'll get that one drawn in there. Again, use a ruler. I'm going to freehand it. And so we get this lovely picture of two lines, which is great, but don't forget, we're trying to actually find the coordinates of the intersection point. So what I want to know are the coordinates of this point right there. That's what my solution to this system is. And if I look, I can see that that solution, that intersection point, is going to be 3, negative 4. Don't forget, since you're writing a coordinate, use parentheses and a comma and all that to write your ordered pair. So there is actually my solution. That's the one point that would make both equations true at the same time. And if you want to test that, go ahead and plug in 3 for x, plug in negative 4 for y in both, and you should see it works. So those aren't too bad to do by hand, but like I said, if your answer isn't a nice, neat integer, if there's decimals, at best it's going to be an estimate. So let me go ahead and show you how to use your graphing calculator to find the intersection as well. So we looked at how to solve this system of equations by graphing by hand. Let me show you how we can use our calculators to get possibly a more accurate answer in case our answer ever is not a decimal, or is not integer, sorry, if it is a decimal, or just as a quicker way to do some of these problems if you don't want to graph them by hand. So in order to graph on your calculator, we'd still have to do what we did earlier in green and blue. We'd have to rearrange the equations to get them in slope-intercept form. So calculator can't do everything for you. You will have to do that part by hand, and I do want to see that work on your homework. But let's go ahead and now graph these two equations on our calculator. So select y equals, and if there's anything in there, make sure you clear it out. If your plots are highlighted like mine are, go up and press enter to unhighlight them. We don't want those plots turned on. So let's graph this equation. We've got negative 4x. Oops, my keyboard does not like when I use the x letter. Negative 4x plus 8. And my second equation was 2/3. We can just do that as a fraction. X, and then minus 6. Okay, if you have a different window, like if you've changed your window, I would just recommend pressing zoom and then 6 to reset it to a 10 by 10. Otherwise, just hit graph if your window's already set up correctly. And we should see what we graphed by hand over here on the calculator. There's one line, and there's the second line, different colors, but yep, looks just like what we got. And we can kind of estimate and look that it does appear to be 3, -4, but here's how you're going to find it more accurately. Press second, and then press the trace key to get to the calculate menu. And in that list, the very interesting option should be option 5, the intersect option. So select option 5, and what we'll do, their calculator is going to ask you 3 questions. They're going to say first curve, second curve, and guess. Really, for what we're doing, it doesn't matter. Just press enter 3 times. I do like to move my cursor over so it's closer to that intersection point. So arrow over so you're close. You don't have to be right on top of it anywhere. Close enough is fine if you're dealing with lines. But get over there close to it, press enter, then 3 times to answer their 3 questions. So first curve, second curve, enter, and then guess, press enter. And what will happen is it will say intersection when you've pressed it enough times. And there we go, 3, -4. Remember, write that as a coordinate, but there's our intersection point. It's a really cool way to do these problems, especially if your answers are not integers. If you have a decimal, this is a great way to get an accurate answer, as well as a quicker way to do the problems.